Colby.math.com.
We're simplifying expressions and using order of operations in this computation help video. If you have an expression like this, the first thing I like to do is identify how many terms are in my expression. Terms are separated by addition and subtraction. So I have 5 multiplied by the difference of 6 and 1. That's a term. And from that I'm subtracting the quotient of 12 and 3 multiplied by 2 squared. So this is another term. So I have 2 terms. And you may say, well, what about this? There's subtraction right there. And that's true that we are subtracting 1 from 6. But since it's inside parentheses, it's sort of like this is an expression within an expression. I've heard this called a subterm, but basically if you see parentheses, it's like everything in the parentheses is representing a final number, some number that we're going to determine later. So if you look at this whole expression, there's really just 2 terms, the first term and the second term. And if we look at PEMDAS for a minute, parentheses, then exponents, and then multiplication and division occur at the same time, that's step 3. Addition and subtraction occur last, that's step 4. If you think about terms, addition and subtraction would have to occur last. I can't subtract this term from this term until I've first simplified these terms down into their final whole number form. And not necessarily whole number, but in any case we have to combine like terms, and we can't create like terms until we first simplify these individual terms. And that's why addition and subtraction always happens last. Parentheses happens first because if you look at this first term, it says 5 multiplied by the difference of 6 and 1. I can't multiply 5 by the difference of 6 and 1 until I first determine what the difference of 6 and 1 is. And so that's why we need to figure out the difference of 6 and 1 is 5. And I'm going to be multiplying that by 5. And then from that, I'm subtracting this term. We have no more parentheses, and so we look for exponents, and here we have an exponent. 2 is being squared. The reason exponents come next is because you couldn't do this multiplication, for example, first. You can't do 3 times 2 to the second power, because if that's what this meant, it would be written this way. It would tell you that the base number was 6, or 3 multiplied by 2. If you look at this exponent, the base number is clearly 2. The 2 is being squared. This product is not being squared. And so you have to evaluate that exponent first and figure out that 2 squared is 4. So substitute 4 for 2 squared, and then rewrite your expression. Then we look for multiplication and division. And I don't like PEMDAS personally, and we'll probably talk about this quite a bit in class. If you understand terms, if you understand how to read the math, in other words, when we get to this exponent, if you understand that the base number is 2, you can't make a mistake like multiplying before you do the exponent, because you would understand that the base is not 3 times 2. In the same way, you work from left to right because, well, I mean, let's do the first term first. It's very straightforward, this first term. 5 multiplied by 5 is 25. But when we look at this second term, it's very common for students that follow PEMDAS to think that they need to do the multiplication before the division. Division is multiplication. Dividing is just multiplying by the reciprocal. So these are inverse operations, and they occur at the same time. We work from left to right because if you look at this term, it says the quotient of 12 and 3 multiplied by 4. It's not telling us to divide 12 by this product. If that's what it meant, if we were supposed to do the multiplication first, it would look like this. And you could have an expression like this, but if that were the case, you would know to evaluate this product first because it would be in parentheses. This is not what we're looking at here. This says the quotient of 12 and 3, and then you multiply that quotient by 4. 3 is not being multiplied by 4. This quotient is being multiplied by 4. So we work from left to right, And then 12 divided by 3 is 4, and we're going to be quadrupling that 4. We still have some multiplication here, so 4 multiplied by 4 is 16. And now we're on to the last step, addition and subtraction. Since we're counting wholes in this term and we're counting wholes in this term, we can combine like terms and find the difference of 25 and 16 is 9. Okay, so I mean, I taught at a school where we never even talked about PEMDAS. It's really not necessary. If you understand how to read the math, you understand terms, and you understand like terms, you're gonna get there without having to go through that step-by-step algorithm following PEMDAS. And another nice thing about it, let me show you this. Another nice thing about understanding terms is if you understand terms, if I understand that I have, it's kind of like a mini expression here and a mini expression here, I can work on both of those at the same time. I can just say 5 multiplied by 5 minus 12 divided by 3 times 4. I can work on, you know, the most important thing to do in this term first is to square this 2, because I need to, the 2 is the base for this exponent, so I need to evaluate that first. The most important thing to do in this expression is to evaluate these parentheses, because I'm multiplying 5 by that difference. And so you can work on both terms at the same time and get, you know, do it in a fewer steps always. And it kind of opens up, well, I'll just leave it at that. But look, you learned PEMDAS, so use PEMDAS. If you're comfortable with PEMDAS, it works for you and you're getting the right answers, use it. I just want you to be able to think about why it works and understand terms, understand like terms. When you're dealing with exponents, think about what is my base and things like that, and understand inverse operations. I want to do one more with you. Let's consider how many terms we have in this expression. Terms are separated by addition and subtraction. I see subtraction here, here, and I see addition here. The subtraction here occurs in parentheses, so that's a subterm, so we'll just consider this whole term is one term, and this is a term, and this is a term. And so if I work on these terms, 64 divided by 8 is 8, and from that I'm subtracting 3 multiplied by the difference of 4 and 3. 4 minus 3 is 1, and to that I'm adding 2. So this is 8 minus 3 plus 2. Here's another case where we're down to the addition and subtraction part of PEMDAS. We have to work from left to right. Subtraction is addition. Subtraction is adding the opposite. So you could express this as 8 plus a negative 3. And so really, you wouldn't do addition before subtraction. You just do whatever you see first. This is, if I read this expression, it says the difference of 8 and 3 plus 2. It doesn't say the difference of 8 and 3 plus 2. It doesn't say 8 minus 3 plus 2. You wouldn't do the addition first because you'd be subtracting too much from the 8. You're just supposed to subtract the 3 from the 8, and then to that difference you're adding 2. And so the final answer here is 7. Okay, I hope that helps with simplifying expressions. You have a lot of practice to do below the video, and I appreciate you taking the extra time to watch the video and work on this.